Good morning, good evening, good afternoon, whenever you're watching the video, welcome. Today's video is all about transformations of polygons, more specifically, translations, rotations, and reflections. All right, there are a lot of objectives, but these objectives are from the first two lessons combined. So, first and foremost, you want to be able to know the difference between a translation, rotation, and a reflection. You want to be able to identify corresponding points before and after a transformation. You want to be able to say, I can use grids to carry out transformations of figures. I can decide which type of transformations will work to move one figure to another. And last but not least, I can use the terms translation, rotation, and reflection to precisely describe transformations. All right. So, first and foremost, a transformation is any change. Okay. So, throughout the unit, you're going to see copies of figures, and those figures will be changed. So, we call those a transformation. There are many different transformations, but we are going to start with a translation. Okay. So, forgive me, I've already got some work done down here. Just go along and write down what you see. All right. A translation is a transformation which slides a figure without turning it. Every point in the figure travels the same distance and in the same direction. All right. So let me zoom out a tad. All right. So we are going to create an image of figure A with figure B. All right. An image is just a fancy name for a copy. All right. So let me see. I'll just erase this and go back through it. All right. So in this translation, we want to slide or translate this figure into a new image. All right. Well, let's just say that I have my points at 3, 5, 3, 2, and 5, 2. All right. Now, in this situation, we want to, let's say, translate this image 6 units to the right and 3 units up. All right. Well, when we are on a coordinate plane or a grid, we have units, don't we? Okay. We have an x-axis, which is horizontal, and then we have a y-axis. Okay. The first number in a coordinate, all right, we have a set of coordinates, which is 2 numbers here. The first number in that set of coordinates is going to be your x value. Okay, your x values are going to lie on that blue line. All right, now your y values are going to lie on the orange line. So whenever we are dealing with units shifting to the left or to the right, we're going to be moving on our x-axis. Whenever we're dealing with units shifting up or down, we're going to be dealing with our y-axis. All right, so in this situation, we're going to translate the figure into an image of figure B is an image of figure A, and we're going to translate figure A to figure B by shifting it 6 units to the right and 3 units up. Well, our y-axis, right, we're going to be working up and down. So if we're going to be going up, we're going to be adding to our y values. Okay. So in this situation, all we're going to do is add 5 plus 3, and we're going to get our 8 in a new point. Okay. This point corresponds with this point corresponds with this one, and that one corresponds with the final point. So now we're just going to take 2, add it to 3, and we'll get our new point of 5. All right. These are the same y values, so they're going to be the same in our image. Okay. Now, the light blue line, which would be our x values, we're going to shift those 6 units to the right. Well, since we're going to the right, just like on a number line, when we go to a right, we increase. When we go to a left, we decrease. So our first point is 3. Let's say we have 3 plus 6. Our new point here is going to be at the x value of 9. All right. Have the same x value here. So that's going to be 9 as well. Here we get a bit different. 5 plus 6 is now going to be 11. You guys just completed your first translation. All right. We know that it is a translation because each point moved the same distance and traveled in the same direction. And also, the figure did not turn. So there is a complete translation. We're going to move on to the next transformation, which is known as a rotation. All right. A rotation turns a figure around a point, which is called the center of the rotation. Every point on the figure goes in a circle around the center of the rotation and it makes the same angle. All right. So an example of this would be figure B is an image of figure A. Figure B is made by rotating figure A around the 0, 0 point, also known as the origin. Okay. Now, we know that this is a complete rotation because every point on the figure goes around the origin. Okay. Here, this point is at 1, 0. Well, if we rotate it 90 degrees in a clockwise direction, that point would end up at the new point of 0, 1. All right. And then you can look and see that every other point has rotated around the center. All right. And that would be the same angle measurement. Every point has rotated 90 degrees around the point 0, 0. All right. Don't get confused. This line is just here to separate. Here you have 0, 0, and there you have 0, 0. And you can see the difference between the two. Excuse me. Okay. Moving on, we have our final transformation. All right. It is known as a reflection. This transformation places points on the opposite side of a reflection line. The mirror image is a backwards copy of the original figure. So let's just take a look at that one. All right. So here we have two figures, figure A and figure B. The one on the left will be figure A, the one on the left will be figure B. Figure B is an image of figure A after it has been reflected about the y-axis. So again, here we have our y-axis. It just so happens to be right. It just so happens to be our reflection line. Okay. Our reflection line does not have to be straight up and down. Our reflection line can be about the x-axis. All right. It can also be about let's say, the line y equals x plus 2. All right. That would be somewhere in here, and then it would just be there. Excuse me. All right. So our reflection line does not have to be an axis, but it can be any line formed on a coordinate plane. All right. So let's use our coordinate points. -3, 1, and -1, 1. And let's go -1, 4. Excuse me. All right. So if I am going to reflect figure A across the y-axis and create the image of figure B, I am simply going to make each of the x values their opposite. Okay. So the reason that I would make the x values their opposite is because we know that here x equals 0. Correct? Well, in order to be a true reflection of figure A, the points on the opposite side of the reflection line have to be equidistant from each other. Okay, so this is 1 unit from the reflection line. So this this point must be 1 unit from the reflection line as well. And since we know that it flips across the y-axis, -1 is going to turn into the opposite, which would be 1. Okay. And since we know that these 2 points correspond with each other on the x-axis, this point is going to be 1 as well. All right. So because you know that you're going to take the opposite of the x value when it flips across the y-axis, what would you guess this point is going to be? You're correct. It will be 3. All right. Now, here's where I challenge you to use your context clues. If I flipped it across, or I'm sorry, not flipped, if I reflected it across the y-axis, did I go up or down? I didn't. All right. So your y values would remain the same, right? So you would have new points of 1, 4, 1, 1, and 3, 1 to have a true reflection of figure A onto the image of figure B. All right. There'll be more to learn about transformations later on this week. You all have a great day. Bye.